Okay, good afternoon. I got the mic to work earlier and then it did not want to work again. And I hope you all can hear me. The last person can hear me. Okay, I embarrassed myself today. I make mistake. And like you all to change this, please. Some student point up to me that IYY is equal to BA³/12 and IZZ is equal to IZZ, the width, this is the width, is AB³/12. Can you make that changes, please? Okay, so I make that mistake. I make the changes over here. I cancel them. Okay, so that's where we were before. Right. So the next thing that I like to clarify with all of you is this. Okay. We're going to define our term neutral axis and centroid. Okay. So sometimes they can be in the same position, but sometimes they are in a different position. So if you look at a lot of times, what a lot of profs do is they say it's the same thing. No, it's different. They're not the same. Okay. So centroid is based on what? Geometry. Neutral axis is based on what? Anyone? Yes, it's based on stress. X or stress must be equal to what? Equal to 0. Okay. So you have to know that the position of the centroid and neutral axis are the same only for what? Centric loading or centric bending. Okay. So it's very specific that only in centric bending is the same position. Okay. Otherwise, it will not be the what? Be the same. Okay. So in centric bending, the position of the, I call it NA, neutral axis, is not the same as the centroid. Okay, so it's centric. So if we look at centric bending, okay, centric, I have to be very careful over here, symmetrical bending. And if we have, if I were to sketch, okay, rectangular, and then our axis, this will be our Y, and this will be our Z-axis. And if we have our moment about Z in this orientation, then we sketch our graph Okay, so I'm going to the graphing mode. I'm going to shift this a bit. Come on, Eugene. So now we're going to sketch. So this is our normal stress in the X position. And for this case, this is our Y. Okay. So we know anything on the right-hand side is positive or tensile. Anything on the left-hand side is negative, compression. And here is our zero in terms of stress. So where our moment vector is pointing, this is compression. Over here is what? Tensile. Okay. So when Y is positive, is in compression, and Y is negative, is in tension. Okay, so you draw your straight line. Now, I'm going to teach you how to sketch your graph. Okay, at zero, at this point at zero, this is where the material is. Oh, this is where the material. So this vertical line over here, okay, this vertical line over here is where the material is. Compression means you sketch the arrow pushing into the what? Into the face of the material. Are we clear? And when it's tension, it is pulling away from the surface of the material. So at this instance, we also know that at this point, I'm going to sketch in green. Okay, at this line over here, based on observation, this is the position of the centroid. Okay. And then based on stress field, we know that at this point, Y is equal to 0, stress is equal to 0. This is known as the what? Neutral what? Axis. So what we see over here under centric and symmetrical bending, right? Position of centroid and neutral axis overlap one another. So they are in the same position. Okay. Now, if we look at eccentric, next we look at eccentric. Symmetrical bending. Okay. So now, again, we have our geometry, this face. Okay. And then we have a moment. So again, this is our y-axis. Over here is our z. Then we have a moment in x. In z. And then we have a force that is pushing in this face, and this is going in as our px. So px is acting on the surface of the what? Material. Okay. So we know moment about z, this is compression. Over here, this is what? Tensile. Okay. So now we know that to calculate the eccentric symmetrical bending, the formula we're going to use is stress x is equal to px over a plus or minus mz over izz multiplied by y. For this case, Px is acting inwards, you call it what? Negative. Are we clear? If Px is acting into the face, it's negative. It's pulling out, it's going to be what? Positive. So for this case, it's going to be negative. So we are going to now sketch our minus Px over A first. Okay, so we are going to sketch our minus Px over A. Okay, so again, this is our stress X. And then we have our vertical. This is our Y. Right? And then the Px over A. This is the line that I'm going to sketch. So again, the center is the material is pushing inwards. So that is our Px over A. Then the next graph we are going to draw or sketch is our Mz Y over Izz. Okay. So now we have our axis again. And then our vertical. So this is our stress X and Y. And we know that it's going what? 4. It's heading in this direction. Compression at the top, tensor at the bottom. Okay. And then pulling. Now, when you put both graphs together, right? So at the end of the day, we need to add both graphs together. Right? We need to add both of them. So when we do that, this will be equal. Hey, don't use spread. Come on. I see whether do I have a bit of space. I need to like squeeze this paper a bit. This graphs a bit. Hold on. Bear with me. It's okay. I just. So this will be equal. So again, our x-axis. Okay, so this is our stress X. And then our y-axis. This is our y-axis. So now, the slope will be the same, but rather now it will shift to here now. Okay. So as you can see, if I'm going to sketch the vectors or the lines to represent compression, we have compression over here. Over here is still compression. Then it goes, not a very good slope. And over here, it goes tension. So now the position of our neutral axis has shifted. So now this is the position of our what? Over here, this is the position of our whereas the line over here, right, where y is equal to 0, this is the what? Centroid. Okay, so for this case, where we have the case where it's centric symmetrical bending, we realize that the centroid and the neutral position or the neutral axis are not the same. A lot of times you see a lot of other examples, they'll say it's the same thing. No, it's not the same. Are we clear? Okay, we have to clarify this. Okay, We're going to do an example now. Okay, and I want you, I think what I've just did in the morning, right, is give you a very quick what? Theory on centric symmetrical, eccentric symmetrical, centric unsymmetrical, and eccentric unsymmetrical bending. Okay, so I'm going to, this is a very quick revision from what you have learned in 2P. Am I right? You have seen all the formulas in 2P before. Am I right? Okay. So now, some of you might ask, so what is the difference that I'm going to teach? This is a revision first. Then we are going to do sandwich material for unsymmetrical bending. Okay. Then we go from there. That's the only part that Dr. Koshi have not done yet. Okay. So let's look at example number 1. And you all have to tell me, what are we looking at, okay? So example number 1, we will have a structure